Okay, so now we're going to look at an example of curl. So first thing is a definition. So the curl of a vector field f, where vector f is f1i plus f2j plus f3k, is defined as the following vector field. So the curl of f is equal to nabla crossed with f, and we have a determinant defined. So we now have to try and find this determinant. So in the same way we did this when we looked at cross product of two vectors. So to find the coefficient of I, the j, and the k, we take it in turns to cover up those columns. So to find the coefficients of I, we cover up the column with I, and we're left with a 2 by 2. And this 2 by 2 would look like this. So the 2 by 2 would be A, B, C, D, and we do A, D minus BC. And we can find the coefficient of I. Now, to find the coefficient of j, we would cover up the column containing j. So this middle column would be covered up, and then we're left with another 2 by 2, and from there we can find j. And don't forget, just like when we're doing the cross product of two vectors, it's a plus, a minus, and a plus. If we do it that way, plus, minus, plus, we don't have to mix up the internals, if you will, of the brackets. Okay, so maybe if we jump into an example. So let's have f equal to x, y, z, I plus x, y squared j plus 3 y z k. Okay, so if we want to find the curl of f, we need to create our options for the determinant. So I, j, and k. So delta delta x, delta delta y, and delta delta z. And now f1, f2, and f3 across the bottom, and f1 is just the coefficient of I, so that would be there, x, y, z, and then coefficients of j are x, y squared, and then finally the coefficients of k, 3, y, z. Okay, so we can now find curl of f, and we'll have so many i's minus so many j's plus so many k's. So to find the coefficients of the i's in the first bracket, we cover up the column containing the I, so that first column is gone, and then we're just left with, what are we left with then? If we cover up the I column, we would be left with this. And then we can do the 2 by 2 determinants on that. So it would be this times this minus this times this. Okay. So let's have a go at that. So the first thing we're going to do is we're going to get, delta delta y of 3yz minus delta delta z of x, y squared. We'll work that out in a minute, but we'll move on to the next one. So to find the coefficients of j, we're going to cover up the column containing j, and then we'll be left with a 2 by 2. So we're going to cover up this column, and then we're left with a 2 by 2. And if we do the determinant of that 2 by 2, we can get the coefficients of j. Okay, so cover up the J column, we have delta x of 3yz minus delta z of x, y, and z. And then finally, let's just drop this down a little bit. So finally, we have plus so many k's. Now, to find the k's, we simply cover up the column containing the k's. So we're going to cover up this column here, and then we're left with a 2 by 2. So it's going to be this times this minus this times this. Okay, so we'll have delta x times x y squared minus delta y times x y z, and we'll have that many k's. Okay, so now we can do the partial differentiation and see what we're left with. So if I look at this first term here, if I do partial differentiation on 3yz with respect to y, I get 3z minus partial differential of this with respect to z. Well, there's no z's in here, so that would be 0. And then minus, mustn't forget the minus in my coefficient of the j's. Differentiate this with respect to x, I get 0. Differentiate this with respect to z, and I get minus xy. And then finally, my k term. So differentiate this with respect to x, gives me y squared. And this term here with respect to y gives me x, z, lots of k. So I have 3z I minus minus, which is a plus xy j, and then finally y squared minus xz k. And that's the curl of f, where f is of course this particular vector here.